Pluto is an intriguing and enigmatic world that lies far beyond Neptune, in the distant region of the Kuiper Belt. This area of the solar system is home to many icy bodies, but none have captured human imagination quite like Pluto. Discovered in 1930 by astronomer Clyde Tombaugh, Pluto was once celebrated as the ninth planet in our solar system. For over 7 decades, it held a special place in planetary science, even though its small size and distant orbit made it difficult to study. However, in 2006, Pluto's status underwent a dramatic shift when the International Astronomical Union, IAU, reclassified it as a dwarf planet. This decision was based on the discovery of other similar-sized objects in the Kuiper Belt, and the realization that Pluto did not meet all the criteria required to be considered a full-fledged planet. Its unique orbit, which crosses the path of Neptune, further sets it apart from the 8 major planets, contributing to the debate that ultimately led to its reclassification. Despite this change in classification, Pluto has never ceased to fascinate both the public and the scientific community. From the beginning, its peculiar characteristics made it an object of great interest. Pluto's orbit is highly elliptical, causing it to sometimes come closer to the Sun than Neptune, and sometimes venture much farther into space. This unusual orbit has led many astronomers to question whether Pluto could ever have been a planet at all by traditional definitions. While some lamented the loss of Pluto as the 9th planet, others were excited by the opportunity to rethink and expand our understanding of celestial bodies in the outer solar system. Today, Pluto is seen as one of the most important objects in the Kuiper Belt, a vast region filled with icy worlds that could hold the keys to unlocking the history and evolution of our solar system. As our exploration of space has advanced, the search for life beyond Earth has become a central focus of scientific missions. Although Pluto has long been dismissed as a lifeless, frozen world, recent discoveries have raised intriguing questions about its potential to harbor life. Traditionally, conditions on Pluto, where temperatures can plummet to -375 degrees Fahrenheit, seemed far too hostile to support any kind of biological activity. Its distance from the Sun, more than 3.6 billion miles at its farthest point, means that sunlight is weak and solar heating negligible. Yet, recent findings have sparked new interest in the possibility that Pluto may not be as inhospitable as once thought. The game-changing moment came in 2015, when NASA's New Horizons mission made a historic flyby of Pluto, providing humanity with the first-ever close-up images and data of this distant world. New Horizons traveled over 9 years and 3 billion miles to reach Pluto, and the images it sent back were nothing short of breathtaking. These stunning high-resolution photos revealed an unexpectedly complex world, with towering mountains of water ice, vast plains of nitrogen ice, and a strikingly heart-shaped region known as Sputnik Planitia. Before this mission, Pluto was largely thought to be a relatively simple, icy rock in space. Instead, scientists discovered that Pluto is a dynamic and active world, with features that suggest it has undergone significant geological changes over time. One of the most surprising discoveries was the existence of ice volcanoes on Pluto's surface. These cryovolcanoes, volcanoes that erupt with ice, water, or other volatiles rather than molten rock, point to the possibility of subsurface activity. Unlike traditional volcanoes on Earth, which are driven by internal heat from molten rock, Pluto's ice volcanoes may be powered by heat generated from radioactive decay within its core. The presence of cryovolcanism suggests that Pluto may still have a source of internal heat, which could mean that parts of its subsurface are warm enough to sustain liquid water, a key ingredient for life. One of the most compelling theories that has emerged in recent years is the possibility that Pluto harbors a liquid ocean beneath its thick icy shell. Evidence for this theory includes the extensional fractures observed on its surface and the lack of significant craters in certain areas, both of which suggest relatively recent geological activity. The idea that Pluto could have a liquid ocean is not entirely new. Scientists have speculated about the presence of subsurface oceans on icy moons like Europa and Enceladus for some time. However, the arrival of the New Horizons mission provided new and crucial data that have bolstered the case for a liquid ocean beneath Pluto's surface. When New Horizons transmitted its images back to Earth, one of the most striking features observed was the vast, heart-shaped basin known as Sputnik Planitia. Located near Pluto's equator, this region is composed primarily of nitrogen ice and spans roughly 1,000 kilometers. Interestingly, Sputnik Planitia lies directly opposite Pluto's largest moon, Charon, While this alignment could be coincidental, some scientists believe it is evidence of a more profound connection. One theory suggests that when Sputnik Planitia formed, it may have been influenced by the presence of a subsurface ocean. Nitrogen gas in Pluto's atmosphere likely condensed and solidified in this frigid basin, adding mass and eventually tipping Pluto into its current alignment. This discovery adds weight to the theory that a liquid ocean exists beneath Pluto's icy shell, and that it may have played a significant role in shaping the planet's surface features. In particular, the chaotic terrain found on the opposite side of Pluto from Sputnik Planitia has drawn attention. This region is characterized by ridges, cracks, and disordered plains, features that have been seen on other celestial bodies like Mars, Mercury, and Jupiter's moon Europa. On these worlds, chaotic terrain is often associated with large impacts, where seismic waves generated by asteroid collisions travel through the planet and cause upheaval on the opposite side. A similar process may have occurred on Pluto, suggesting that its icy surface may hide more secrets about its geological history. Further research and computer simulations have supported the idea that a massive collision could have sent shockwaves through Pluto, creating these distinctive features. Graduate student Alden Denton, specializing in planetary geology at Purdue University, ran simulations that showed how an asteroid impact could create such seismic waves. These models further support the hypothesis that Pluto may have a liquid ocean beneath its surface, which would be necessary to explain the transmission of seismic energy across such a large distance. While these studies provide strong evidence for a subsurface ocean, other observations have also pointed to the presence of water on Pluto. For example, images of the near side of Pluto show water ice impregnated with organic molecules. Though it may seem surprising to find organics on a world as cold and distant as Pluto, laboratory experiments on Earth have demonstrated that solar and cosmic radiation can drive the formation of complex organic compounds, including the building blocks of RNA and DNA. This raises the tantalizing possibility that Pluto could harbor the necessary ingredients for life, even if only in microbial forms. Adding to the excitement, New Horizons also detected a reddish band at Pluto's equator, which could be composed of organic materials. This region corresponds to an area of greater solar exposure, where slightly warmer temperatures might allow for the existence of liquid water or other volatile compounds. The presence of organic materials in conjunction with water is critical because these two components are considered essential for the development of life. However, not all observations have been as straightforward. Some UFO enthusiasts have interpreted anomalies in the images of Pluto as evidence of artificial structures. One of the most debated features is a smoky trail visible on the planet's surface. While NASA scientists have explained this as a natural phenomenon, possibly linked to cryovolcanic activity or atmospheric haze, some believe it could be proof of extraterrestrial life or technology. These theories remain speculative, but they highlight the public's enduring fascination with the possibility of life beyond Earth, even on a world as remote as Pluto. In conclusion, Pluto remains one of the most mysterious and captivating objects in the solar system. Though it has been reclassified as a dwarf planet, its complex geology, potential subsurface ocean, and intriguing surface features suggest that it is far more than just a cold, distant world. The New Horizons mission transformed our understanding of Pluto, revealing it to be a dynamic and geologically active planet with the potential to harbor some form of life. As scientists continue to analyze the data and plan future missions to the Kuiper Belt, Pluto's secrets may yet offer new insights into the nature of the outer solar system and the possibility of life in the most unexpected places. If you found this exploration of Pluto captivating, don't forget to like, share, and subscribe so you won't miss out on more fascinating content in the future. Thank you for watching, and I'll see you in the next one.